All right, here's my video guide for 10.1.5. It's our last section of 10.1, so we're going to move away from circles after this lesson and get into some new stuff in 10.2. So here being the last lesson, we're going to review some circle relationships. We're also going to kind of review on how we find circumcenters in one problem. And we only got 3 problems here today. And I've changed things around a little bit, so 10-50 I changed, and so I'm going to be hopping to the lesson that you guys have to do that problem, and then I'll be coming back to my Smart Notebook file to do the last 2. Let's get going with 10-50 right away. It is a problem, like I said. I'm going to move to your lesson here, the hard lesson that I'm going to give out to everybody. And if you look at here, I am actually going to be using this Desmos e-tool. So I put a link here that you can copy and paste, and I already have mine up here. It's just that same Desmos geometry tool that we've been using before. All right, so if we start this problem, it says on a map, coordinates of towns A, B, and C are going to be at A minus 3, 3, negative 3, positive 3, B positive 5 to positive 7, and C positive 6, 0. And then just move into A. The first thing we're going to do in this problem is we're going to go to Desmos. We're going to turn on the grid setting so we have a grid to work with. And it does say that if you don't understand it, watch this video. And then we're going to plot the points that we need to plot. So I'm going to go to my Desmos, and what you do is you go to the wrench up here and you do show grid. So you get this grid format here. And then what I do, because it doesn't give you a clear coordinates, I go to the line button and I make just a kind of an easy XY coordinate. So there would be my X, here would be my Y. And then I actually have kind of like my grid paper set up here. I like to put it down here a little bit lower because my coordinates end up going a little bit higher. So the first one I'm going to plot is A. So we're going to plot that A coordinate at negative 3, positive 3. And so we'll go take a point. We'll go minus 3, 1, 2, 3 backwards, and then up 3. And that's our first point A. And I'll label it A. The second one is going to be at 5, 7, positive 5, positive 7. So we go over 5, 1, 2, 3, 4, 5, up 7, 1, 2, 3, 4, 5, 6, 7. And you can kind of see why I like to have my X and Y axis a little bit lower, because 7 is all the way up here. And then we'll plot that last point, 6, 0. And you just go over 6, up 0. So 1, 2, 3, 4, 5, 6. And I should label these points. This one was B, and this one was C. And I think that's just part A right there. I think it just wants us to plot the points here. Oh wait, it says plot the points A, B, and C, and then connect them to form triangle ABC. So I'm going to connect them right away as well. And I'm going to connect it so it's A to B, B to C, and C to A back. So we get this triangle here. And then that, I believe, is, that's the first part of it. Sorry, that's not the one I want to look at. This one here, that's the first part, part A. We have the points plotted, and we've created the triangle. And we have the 3 cities and really these straightaways that would take us there. But we are not trying to talk about a triangular highway. We want a circular freeway. So we want to find a way to create a freeway that is circular, that goes to each city. So following the directions, we go to part B, and it says now create perpendicular bisectors to the lines AB, BC, and AC, and then answer the question about where do the coordinates intersect. And so we're going to go back here, and I'm going to do this the quick way. You could do 2 circles and then intersect the circles and draw the perpendicular bisectors this way. The way I'm going to do it is I'm going to use that More Tools button, and I'm going to use midpoints. And so I get one midpoint here, another midpoint here, and another midpoint here. And I'm using those midpoints because when you use a midpoint, it bisects the line. So we already have the bisecting part, and I just need the perpendicular part to it now. And so I go then to perpendicular line, and I create perpendicular lines on these midpoints. And so I got one perpendicular line, another perpendicular line, and another, and they all pass through that midpoint, which means they are perpendicular bisectors. because a perpendicular bisector is just a perpendicular line that cuts that line in half, and going through that midpoint means it's cutting that line in half. And so actually we do get this point of intersection right here, and I'll call that, I'm going to call that C. Actually, no, we already have a C. I'll call it G. Why not? And I think that's what we needed here. It says we needed to create perpendicular bisectors to all the lines, and then, oh, and what coordinate does the perpendicular bisector intersect? That coordinate is, if you go over 2 and up 3, that's the coordinate. So 2, 3, positive 2, positive 3 is the coordinate there. All right, now it's actually time for part C, and it's time to construct the circular freeway. Use the point of intersection from the perpendicular bicenters as the center of your circle. Once it is centered, extend the circle so that it intersects one of the triangle's vertices, and then I'm going to copy and paste the screenshot. So what that's saying is I'm going to take a circle, I'm going to center it at G, and I'm going to extend it to my vertice. And now we've seen this before, and I'll answer that in part D, but we've seen this kind of relationship before where I extend that circle from that point of intersection, and if you look, it intersects all the points, all the vertices of that triangle. Very special relationship, and that actually is how we'd have to construct this highway, because now if this, sorry, I gotta get rid of that circle I accidentally created there. Now if you picture that this green circle is your highway, we have a highway that goes through each one of my towns, which is a really special relationship, and we'll answer that in part D. But before we answer that, I want to take a picture of this and put it into, try the best I can, it's not going to be perfect here, but I just take a picture, put it into my work here. I'm going to shrink it down a little bit. And then we move into part D, and part D is saying what is that point of intersection called and why is it special? That point of intersection is called the circumcenter, and maybe some of you remember that we had to do a homework assignment with a bunch of vocab, and circumcenter was one of them. And why is it special? It is equidistant to all the vertices. So those are the two big things. That's what's really special about that point where all the perpendicular bisectors intersect. That's our circumcenter, and the circumcenter is special because it has that same distance to each vertice. Or like in this case, you can visualize it by seeing that circle. It's got the same radius from G to C, from G to B, from G to A. That radius is the same, so we know that's equidistant. And I could take it a step further and ask, well, what is that radius? And really, because of this grid, it's nice. I can just say 1, 2, 3, 4, 5 units that distance is. And I wonder if I do this, kind of talking a little much here, but let's see if this works. If I highlight this, and yeah, so it does do it. It has a label of 5 for that one. If I go to C, it should have a label of 5. If not, I'm doing something wrong. 5, yep, and it would be for B as well. Same radius. All right. And that's all for that first problem. Just a kind of a recap of what a circumcenter is, and why it's cool is because it's equidistant to all the vertices. Okay. We're going to start 10-51, but I'm going to go back to the Smart Notebook file so I can work on it there. And I really like this problem. It actually took me a little bit to try to figure it out. And I'll try to do it as quickly as I can here. I have 5 minutes left on my video. So it says an 8-inch dinner knife is sitting on a circular plate. I want to get rid of some of these. It's annoying me. There you go. An 8-inch dinner knife is sitting on a circular plate so that the ends are on the edge of the plate. If the minor arc that is intercepted by the knife measures 120 degrees, find the length of the diameter of the plate. So really we know that there's a chord pretty much that's 8 inches, and we know the minor arc for that chord is 120 degrees. And so I'm just going to try to fill in the information I know right now. We have a circular plate. We have a dinner knife sitting across it that is 8 inches. I'm going to put that in there, that's 8. And we have, we know that this minor arc up here is 120 degrees. Okay. We need to figure out what the diameter of this plate is, and we're going to use a bunch of different geometry things we've done with circles to try to do that. The first thing we need to remember is that if we're going to do a diameter of this circle, we can make a diameter so that it is a perpendicular bisector of this chord right here, because diameters can be perpendicular bisectors of chords pretty easily. So I'm actually going to move this 8 out of the way for a second, and I'm going to make that perpendicular bisector. And it's not going to be perfect, but we're going to try our best here. We'll say that is the diameter, and that's the perpendicular bisector of that diameter. Because that chord is getting bisected, it is now getting split, and so it's not 8, it's 4 over here, and it's 4 over here. Okay. What else can I say so far? We'll get rid of the 8 here. What else happened? Nothing I can think of right now. The next thing I'm actually going to do is create 2 different triangles. And so I'm going to, because we have a bunch of right triangles actually, I'm going to create a right triangle right here. And I'm going to create a right triangle right here. So I got these 2 right triangles now, and if you notice, my goal is here to use trigonometry to figure out, and I'm going to use my pen here, what this distance is right here. I got to click my pen again. What this distance is right here, I'll call it x, and what this littler distance up here is called, and I'm going to call it y. Because if I can have x plus y, I have my complete diameter. And I think it is going to be possible to do, to find x here and y because of some of the relationship stuff we know. The first thing, I'm going to erase my x and my y for right now. The first thing I'm going to see is that this could also be a complete triangle here. And what then this becomes down here is an inscribed angle. And we know this is the inscribed angle, and the inscribed angle creates 120 degrees out here, which means this whole entire angle here, that whole entire angle here is 60. Because your inscribed angle is always half of what your arc measure is that it creates. So that whole thing is 60, which means just half of it here is going to be 30. So we have 30-degree angle there, and I'm going to do the same thing up here. We know that if this arc measure, the minor arc measure is 120, the major arc measure is going to be 240, because that completes the circle and gives you 240 plus 120, 360. All right? If the major arc measure is 240, that means that this inscribed angle down here, the entire inscribed angle here, is going to be 120, because it's always half of the arc measure that it creates. Now, if I cut that 120 in half again, because I just want 1/2 of this triangle, so I cut that part out, I take 120 cut it in half, and that gives me 60 right here. So I actually have quite a bit of information now. I have a right triangle. I have this right triangle right here that has 30 and 4, and I'm looking for what I called x. I'm looking for that missing side. And I have an angle, a right triangle up here that has 60, a 4, and this missing side that I'm going to call y. If I can find x and I can find y, and I can add those 2 together, I can find that total diameter, and that's what I'm going to pick up on in the second video.